Hi, hope you have seen this transformer. Sometimes it could be a small or big size. A transformer is a passive electrical device that transfers electrical voltage levels from one circuit to another through the process of electromagnetic induction. It is mostly used to increase the voltage levels between circuits, which are called step-up, or decrease the voltage, which is called step-down transformer. Today, this video going to explain the working function of the transformer. Let's start with the main parts of the transformer. The core is the main part, and it is called the heart of the transformer. The core is made up of iron or silicon steel or ferromagnetic materials. It is thin metal strips and lamination insulated by a coat of varnishes or papers. The core of the three-phase transformer consists of three limbs in the same plane, and each limb carries both low voltage, LV, winding, and high voltage, HV, winding. The core provides a magnetic path flux around the core. The first winding is also known as a coil. When it is supplied by an alternating electrical source, the alternating current through the winding produces a continually changing and alternating flux surrounding it. If another winding is brought close to the first winding, some portion of this alternating flux will link with the second winding. As this flux is continually changing the amplitude and direction, there must be a changing flux linkage in the secondary winding or coil. According to Faraday's law of electromagnetic induction, there will be an EMF induced in the second winding. If the circuit of this secondary winding is closed, then a current will flow through it. This is the basic working principle of a transformer. The winding which receives electrical power from the source is known as the primary winding. The winding which gives the desired output voltage due to mutual induction is commonly known as the secondary winding. Here, if the number of secondary coil turns is greater than the number of turns primary coils N1, then it is called a step-up transformer. That means increasing voltage between the primary to secondary windings. Conversely, a transformer that decreases voltage between the primary to secondary windings is a step-down transformer. The alternating current through the primary winding of each phase produces a continually changing magnetic field that surrounds the winding. Here this magnetic field is linked with the secondary winding by magnetic flux, which flows through the transformer core. EMF will be produced at the secondary winding based on Faraday's law. And this induced EMF is defined as mutually developed EMF. Insulation is needed between the primary and secondary winding to prevent short circuits. Finally, to receive electric energy from the transformer, insulated bushings are needed. During its working, or transferring the power from the primary to the secondary winding, various energy losses happen. Like eddies current losses, hysteresis losses, and copper losses. All these losses generated heat. To prevent heat, transformer oil is used inside the tank. The main role of transformer oil is to act as a coolant and to insulate. Transformer oil is an exceptional heat conductor, and can effectively reduce the copper coil's temperature, stopping them from burning. Not only that, externally cooling tubes or radiators are there. The radiator of the transformer accelerates the cooling rate, thus it plays a key role to increase the loading capacity of an electrical transformer. A Buchholz relay is used to detach any fault inside the transformer. Hope you understand the working function of the transformer. Thank you. Let's grow up. Never stop learning.